Good afternoon, and thank you for coming. I'm Bob Howarth. On behalf of Tony Ingraffea and myself, I'm pleased you're here. Our purpose today, I'll go into a little bit more detail here, but is to tell you our thoughts about methane and the greenhouse gas footprint of natural gas generally and shale gas. Tony and Renee and I published our first paper on that topic 4 years ago tomorrow. So we're here partly to celebrate and partly to review the science and bring you up to date on what we think has been happening since then. So I will start, Tony will interject in here in a while, and I'll finish up again. So we started working on this topic in the fall of 2009. At that time, shale gas was still a new phenomenon. This shows the trends in shale gas production in the United States, and shale gas is a primarily U.S. phenomenon. There's some development in Canada too, but this is the global trend, the U.S. trend, and we weren't there at the very start, but we got in thinking about it fairly early on. We published our first paper on the topic, as I say, April of 2011. It took us about 2 years from the time we started working on it to get it out. Shale gas was still fairly new. The developments proceeded. Since then, the science has progressed at an incredible pace since then, which is mostly what we'll talk about today. This is the paper. It was published April 15th, 2011, online. And the question we took on then, and the question that we're addressing today is natural gas generally, and shale gas specifically, truly a bridge fuel? It's widely promoted as a bridge fuel. The President Obama, proclaims it's a bridge fuel. Industry does. Many environmental groups do. Is it? The evidence that it might be is this, simply the carbon dioxide emissions from using natural gas compared to oil or coal. For the same amount of energy, the carbon dioxide emissions from using natural gas are substantially less than from those other fuels. So in that sense, it is clean burning, it is good. But that's only part of the story. The other part of the story is that natural gas is mostly methane. Methane is an incredibly potent greenhouse gas, and so you need to look at the release of methane to the atmosphere when you use natural gas, or shale gas specifically. And that's what we took on as our research challenge originally. That's what I'm updating you on today. This is from our paper from 4 years ago. These are the chronological listing of people's estimates from the amount of methane that's emitted to the atmosphere as conventional natural gas is developed or as shale gas. Ours is the first published study which actually looked at emissions from shale gas. People had not. The time our study came out, EPA was relying on a study going back to 1996. They said that over the lifetime of a gas well, from the well itself to final consumer use, 1.1% of the natural gas is emitted to the atmosphere as methane. There was a Department of Energy study, peer-reviewed publication, that said it was somewhat higher, that came out in 2002. There was this paper out of the Carnegie Mellon Group, which really did not use independent data. They just used the EPA numbers. And then we came out with these numbers. We're saying there's substantially more methane emissions from shale gas, and our estimates are similar to the DOE study, but pretty uncertain. I want to say now, and I'll say several more times, that the quality of the data we had available to make those estimates was very poor. Poor information, poorly documented. We used the best available information we could, and to this day, I think we did the best job one could do to synthesize it. But one of our conclusions was that it was a poor quality of information. At the end, I'm going to tell you that I think these estimates have stood up surprisingly well, much better than I ever would have imagined from 4 years ago. Using those methane emissions, we could compare the greenhouse gas footprint of shale gas and conventional natural gas versus other fuels. And we're doing that here on two time scales, a 100-year integrated time frame from when methane might be emitted to the atmosphere, and a 20-year time period. We'll look at the 100-year here. The blue is the amount of carbon dioxide that is used to produce a unit amount of energy, so grams of carbon per megajoule of energy. The red is the indirect emissions of carbon dioxide that you use to obtain the fuel, mining coal, moving it, whatever. And the magenta color there is the methane emissions converted to equivalency of CO2 emissions. And we'll talk some more about how that's done. So at the 100-year time frame, at our high estimate of what methane emissions might be, this fuel is actually worse than, say, coal or oil, not better, not a bridge fuel. For conventional natural gas at our low estimate, then yes, okay, it's probably less of an issue at the 100-year time frame, but not as much as you'd determine if you ignored methane, just looked at CO2. The shorter time frame, methane is much more important in the consideration, and so natural gas and shale gas look proportionately worse. And our provisional conclusion 4 years ago was these are not bridge fuels. Our conclusion today is they're not bridge fuels. We got a huge amount of media attention from the start. This came out on the front page of the business section of the New York Times the week our paper was published. As the author says, our findings are certain to stir debate. That's true, because it cut into the idea that this is a bridge fuel. And we were challenging that directly. We continue to challenge that directly. At the end of 2011, Tony and I got written up in Time magazine in the Person of the Year issue as some of the runners-up of the Person of the Year, if you will, the people who mattered, because of the publicity that our work got. We're not people who mattered because we're nice people. We are nice people, but that's not why we're here.
There's two nice people up there.
That's our friend Mark Ruffalo. We got there because the people who mattered are people who are newsworthy. And these are other people in 2011 who were newsworthy. My personal favorite is Joe Paterno, I suppose. I don't know. I'm just pointing this out to say that we got a lot of publicity. And associated with that, we got a lot of attention from politicians, other scientists, and from industry. So that's part of our story, but I'm going to stick to the science mostly today. And I want to focus on what we've learned or what's been reported in the 4 years since this week of 2011. And I want to see how well our study has fared. I want to start with the Intergovernmental Panel on Climate Change, which came out with their 5th synthesis report in 2013 and 2014. And they tell us that the last decade was the warmest on record ever in recorded history of measuring temperature on this Earth. If we go back with the geological record, the last decade was the warmest within the last 120,000 years. And in fact, 2014 was the warmest year on record, period. Before the last decade, the decade before that was the warmest, and the one before that. We're on a strong warming trajectory here. And the rate of warming is the fastest it's ever been, the IPCC tells us. It's a result of greenhouse gas emissions, and if we look at the cumulative influence of greenhouse gases on the heat trapping capacity of the atmosphere, which is described here as anthropogenic radiative forcing, don't worry about the terminology, just look at the size of the bars. The human influence of greenhouse gas emissions to the atmosphere now, in 2011, is 4 times larger than it was in 1950 and 2 times larger than it was in 1980. So this problem is getting worse. I am more alarmed now than when we wrote our paper 4 years ago. The gases that are primarily responsible for that are carbon dioxide and methane, according to the IPCC. The units they use to describe this heat trapping are watts per square meter. It's an energy unit. Carbon dioxide is 1.66 watts per square meter, and methane is about 1 watt. So they're both pretty important. This is also from the IPCC report, and here they're looking at different time frames, a 10-year time frame, a 20-year time frame, and a 100-year time frame, how the major greenhouse gases compare in terms of their current emissions, not necessarily how it's playing out in current warming, but their current emissions. And the first bar there is carbon dioxide, the second one is methane. So at this 10-year time frame, what they're telling us is that globally, the methane emissions currently equal or exceed in their heat generating capacity what carbon dioxide is doing. 20 years less so, carbon dioxide is worse, and again, further out in the future you go, methane's less of an issue. But these shorter timescales, the IPCC, which had not really talked about this in their earlier synthesis reports, says you need to pay attention to these short timescales and that methane's a big whammy. The other piece of new science which came out after our report, this is outgrowth of UNEP work, is published by Drew Shindell, who was at NASA at the time, in Science back in 2012. And what they say is that the Earth has warmed over the 20th century by 0.7 of a degree Celsius. We're on a trajectory to continue to warm unless we do something dramatic with greenhouse gas emissions. If we follow the reference case here, the green line of doing nothing to control greenhouse gas emissions, we will hit a temperature of 1.5 degrees in about 15 years from now, and 2 degrees in about 35 years from now. We were not aware of that when we published our paper 4 years ago. And again, this is of huge concern to me. Those are dangerous temperatures at which you start to worry about the climate system fundamentally unraveling. What can you do about it? Well, what this paper says is that if you control carbon dioxide emissions but ignore other greenhouse gases, you'll do that blue line. We will still hit 1.5 to 2 degrees Celsius in the time frame of 15 to 40 years from now if we control only carbon dioxide. If you want to get on that lower line there, you need to control methane. There's no other way to slow the current rate of global warming. And I just want to hammer that because the science behind this was not as well developed in our paper came out 4 years ago. As I say, it's increased my level of alarm. Methane and carbon dioxide are both carbon, but they're both critically important to climate, but fundamentally different. So for carbon dioxide, you put it into the atmosphere, it's going to have a climate influence for thousands, tens of thousands of years because it's taken up in the ocean, it's re-released, it's going to buffer the atmosphere, it's a bad thing to do. But because of lags in the climate change system, controlling it now does nothing immediately. We need to control it, but it doesn't help with the immediate problem. Methane, on the other hand, is only with us for a decade or so, then it's gone. The long-term influence in climatic warming is really small unless we fundamentally alter the climate system, which we may well if we hit 1.5 to 2 degrees. And then we're in a very different situation, and the damage done by methane will be with us for tens of thousands of years again. So reducing emissions immediately, unlike CO2, slows global warming. We need to do that. Again, that's all new science since 4 years ago. The time frame. I showed you our picture of the summary of how emissions affect the greenhouse gas footprint on the 20-year time frame and the 100-year time frame. These papers are listed chronologically. Those are some of the papers I mentioned that came out before ours on natural gas in general. These papers all came out after ours. For the most part, they came out within 6 to 7 to 8 months after ours, which was remarkably fast for science. The ones in black only look at a 100-year time frame. The ones that are in blue look at shorter time frames of various sorts. We looked at the shorter time frame. We'd followed a good tradition, I think, in doing so. In retrospect, I think it's even more critical that we do so, had done so, and that we pay attention to that shorter time frame. These studies did not, and many of these not only didn't look at shorter time frames, but explicitly criticized us for having done so. The IPCC picked up on that. And they very explicitly said in 2013 that there's no reason to look at the 100-year time frame as opposed to others. It's completely arbitrary, and that the time frame you choose depends on your concern. And if you are concerned with what methane emissions are going to do over the next 15 to 40 years, then you need to pay attention to what methane does on those timescales and not just 100 years, which greatly devalues it. So I think we made a good decision in using the 20 and 100 years. The IPCC explicitly supports us in this. Our critics were wrong. I'll say that again, our critics were wrong on that point. And in retrospect, I think we should have given more emphasis to the shorter time frame than we did. And I've started to do so since. This shows another way of looking at the emissions. Again, the Department of Energy study, some EPA things compared to our study. I'm now separating the emissions into the upstream emissions, what happens at the site of a gas well or a gas field, and the downstream emissions, which come from storage, long-distance transmission, and distribution pipelines, and then the total. And I want you to pay attention mostly, well, to a few things here. There are really only two estimates out there until very recently for what downstream emissions are. It's either 0.9% of the lifetime production of a well or 2.5. We're with the DOE. The EPA has a lower number. I think there's still huge uncertainty in that. I'll come back to it in a bit. On the upstream emissions, I want you to pay attention to what EPA did. Prior to the time our paper came out, they were saying it was 0.16%, and they've been saying that since 1996. They reanalyzed it in 2011, and they came out with a number that's virtually identical to ours, despite what critics tend to say about we're not in agreement with EPA. We lost our agreement after that because between 2011 and 2013, the EPA cut that emission estimate in half again, and I think in a way that is just not supported by the science. And in fact, they've been explicitly criticized by the Inspector General of the U.S. Environmental Protection Agency for doing so without science to back it up. I showed you the various papers which came out right after ours and how some looked at the 20-year time frame, others said just 100-year. This is basically the same set of papers listed chronologically, and again, most of these are either predating us or very quickly within 6 to 8 months after ours. These are what those various papers said for methane emissions, and we published a critique of this way back in 2012. I don't want to go into it today because there's much more interesting information that's become available. There's a lot I could say, but the point is we used poor quality data for our study. Those studies all use poor quality data for their studies. So let's go on and look at what's happened since, because there are newer, better sources of data that are out in the meanwhile. Tony wanted me to explicitly tell you that the EPA estimates are bottom up. They're looking sort of process by process, equipment piece by equipment piece, adding them up. And they are using data which is supplied largely by industry. We'll come back and talk about some of that. So one of our major conclusions, I've said it now, I said it when we first gave a talk on this work 4 years ago, the data we used were poor, extremely limited. Natural Gas Alliance has videos of me speaking in this very building saying the quality of our data are really poor. And then they goes, so why did Howarth and Ingraffea publish it? Well, because it was the best available information and it tells sort of a damning story and it's an incentive for people to do better. But we also said that there's a great need to get better data and to have it more free from industry. And I was pleased actually in preparing for this talk today, I went back through the New York Times article that came out 4 years ago in a paper, and I'm quoted explicitly as saying that. I don't think our paper is the end of the story. We ought to be doing a better job of making measurements. And I'm proud to say that our research has gotten a lot of people interested in doing precisely that, and there are a lot of new measurements. I'm going to turn this over to Tony for just a bit. Let me just give my personal take on this. I met with Lisa Jackson, who is the director of the Environmental Protection Agency, in December of 2011 to talk to her about our research. She said she'd given a briefing to President Obama a couple of days before on our research. They were well aware of it. So from the very start, our paper has gotten attention from agencies and continues to do so. Tony?
Thanks, Bob, and let me add my thanks to all of you for coming. You're probably wondering why I've been sitting all the time listening to Bob. That's usually the situation.
You saying I talk too much?
Now, so I volunteered as my part of this presentation to try to address some of these specific criticisms that our initial paper received and try to place them in the context of what's happened since. So as Bob pointed out, we were very thrilled to hear what the former Secretary of the Department of Energy said about our work in public. He basically, if you listen to the video of this, it's almost he's apologizing for being so impolite as to say that we're just not credible. Of course, industry picked up on that, and so the word that most often comes up when you Google Howarth or Ingraffea is the word incredible. I'm sorry, non-credible. You got it. Enough with my sense of humor. But as I said, I wanted to respond to this because this is late 2013. This is somebody who represents the White House saying methane emissions, not so much. A year and a half later, as part of its U.S. National Climate Assessment, there's a major part of this climate change impacts in the United States report out of the White House that addresses really large methane emissions. Wow. And within 3 months, the White House issues its own climate action plan strategy to reduce methane emissions. What we did was not credible, but within 2 years, the White House is saying the issue is really important. Since then, those of you who know that there's, former Senator of New York State and our Secretary of State, Hillary Clinton, flew around the world organizing the Global Methane Initiative, suggesting that many of the major countries around the world and some of the emerging nations who are at the cusp of trying to figure out whether they want to go fossil or renewable should take into account methane. Wow. And more recently, the EPA, despite having backed down last year from its initial increase in estimate of methane emissions, now has 5 white papers out for public comment. And as you probably know, the EPA begins a possible regulatory regime by starting with white papers for public comment, and that precipitates ultimately rule changes, perhaps. So these white papers are all about methane emissions from various locations along what Bob and I refer to as the life cycle of natural gas. So the first of the 3 times I'm going to come up here, my point is, at first our work was not deemed credible at the White House level. Very quickly thereafter, the issue we were addressing, perhaps we're still not credible, but at least the issue that we brought to bear is credible. And we now have very major activities out of the White House directly and out of the EPA and also out of DOE and also out of Bureau of Reclamation to address methane issues. So Bob said we're proud of what we did. We're more proud than ever because we did what we asked in our first paper for everybody else to do, get on the science. So back to Bob. I'll be back.
Thank you. So what I want to do now is to move on to the new science on methane emissions. And these are papers which have been published since 2012. They all give estimates of methane emissions. The first several are on the upstream emissions, so well site or field site for unconventional gas, shale gas, or other unconventional gas. There are a couple of brand new studies just in the last few weeks to a month or so for the downstream emissions I'll talk briefly about. And there are some new estimates for the average of natural gas in general, and we'll talk to those. I'm going to start with 2 of these studies just as representative, and then I'll compare and contrast some of them as well. The one I want to start with is a paper by Dana Carlton, a graduate student at Purdue. Tony and I are co-authors on this, as is Renee Santoro and also Jed Sparks here from Cornell. And unfortunately it wasn't me, it was Paul Shepson, flew this airplane back and forth. That looked like great fun. I was sitting on the ground talking to him, but this is an airplane equipped with methane monitors. We flew it over southwestern Pennsylvania back in June of 2012. And in this particular plot, you're looking at the horizontal distance in kilometers away from a recognizable gas rig on the ground and up in the altitude above ground. So flying back and forth, you can see the hotter colors are higher methane. When they see a higher color, they circle around, they map it, and you can pull the data together and you get a recognizable plume like that you can quantify with some specificity. We can also look at the change in the methane concentration over a day and together with meteorology, come up with sort of a landscape scale estimate. The landscape scale estimate that we got out of this suggested that the numbers which we had published originally in 2011 were a little too low. But not within, we couldn't conclude that with certainty because the error associated with this and the rain we published are both large. So they overlapped, but this is at the high end. The more important thing about this paper is that that particular well I just showed for that plume, which is a large emitter, was not alone. There are other large emitters, several drilling pads releasing large amounts of methane to the atmosphere from wells which were still being drilled, had not yet reached the Marcellus Shale, had not been fracked. And we and the EPA and I think everyone else in the world had assumed there were no emissions until you get in and hit the formation. So it's a surprise, right? One of many surprises that I think are still out there to be learned about methane emissions. I think you're on again next. Yeah, blank means Tony.
Yeah. I'll take that. Good. So again, remember, my job here, this is the second of 3 tries, is to try to directly address some of the criticisms that we got from our first paper, from our colleagues over in EAS in particular. So I'm going to show videos of what they said could not happen. Now, recently in the news, we've seen video evidence of people, never mind. Videos are really good examples, or really good proof that things do happen, unless you think I'm making the videos up. So, I'm going to show you 5 videos, not very long, just snippets of them. On some of these, I was present when the video was done. I vouch for the authenticity of each of them because I know who did them and where they were done and where they were done. But I'm going to show you large point source emissions of methane by direct venting, which we were told back in 2011 never happens. So I'll show you a blowdown from a compressor station, a blowdown from a pipeline pig and transfer operation, venting during drilling. Bob just pointed out that everybody was shocked, including us, when we published our paper that showed, this research behind the paper showed that there's a lot of methane emissions during the drilling of a shale gas well. Blowdowns from shut-in wells, and finally leakage from orphaned and abandoned wells. So, excuse me while I find my glasses. Turn off the PowerPoint momentarily. I'll remember to put it back on, Bob.
Thank you.
And let's go to videos. So you all know what a compressor station is. So this one, I was present.
Been going on for half an hour now. I called 911. Guy, subcontractor here, painting.
Not only went on for a half hour, went on for a whole day. Calling 911 to report a compressor blowdown in Pennsylvania is not a useful activity. Anybody live in Ellis Hollow? How many times have you heard a blowdown from? Okay, now you know what it is. Okay, let's go from a compressor station to a pipeline situation. I witnessed this. I'm standing on the back porch of a private home. The boundary of the private home is right here, property line. That's a venting going on. You can hear it. And if you wait just 1 minute, there was something else our critics said, which is direct venting is extremely dangerous, and no oil or gas personnel would ever allow it to happen. All right, let's go to a well site. This is a video taken by my friends at Earthworks. Transparency, I'm on the board of Earthworks. A gas buster is a device on a drill pad that separates methane from drilling mud. This is using FLIR. At the time we published our paper, and very soon thereafter, when I was going around giving talks showing FLIR video, I was loudly and roundly criticized by people in the industry and some of my colleagues saying, FLIR can't show anything. Well, FLIR is now being promoted by many states as required in their revised regulations as a method of detecting methane emissions. And the industry has been using it for decades. It's just that the critics didn't know that. So there's methane emissions during drilling. This one I like very much because I was here when this one happened. I'll tell you a little story. You see the highway here. We had to go to the other side of the highway because if we went to the other side of the highway, we were reported, and then the natural gas police show up. So what's happening here, I'll replay it. Before I replay it, let me tell you. A shut-in well is a well that has been drilled. Perhaps it has been fracked. This case is a well in northeastern Pennsylvania, Bradford County, that was drilled, it was fracked, but since there was no pipeline available to bring the gas to market, it was shut in. That is, a valve is put on the wellhead and nothing comes out of it, except pressure continues to build over time. And once a day, the guy in the white pickup truck, I saw him, drives onto the site, runs up to the wellhead, turns the valve, runs back to the truck, and drives as fast as he can to get away. So I'll show you that one again. That goes on for a few hours at a time every day. Now, there are about 8,700 shale gas wells that have been drilled in Pennsylvania. About half of them are not yet in production. So one of the things that we don't know, there's so much data that we don't know how many shut-in wells there are that are being vented every day. But that's not included in any EPA estimate bottom up. It's picked up by top down, of course, when it happens.
Would the valves not stand that pressure, or is that why they've done it?
Yeah, basically, you don't want to over pressurize the casing.
And then it stops, and they go back and shut it?
Yeah, that's exactly what happens. And finally, the last one I'll show. It's now estimated that in Pennsylvania alone, there are between 300,000 and 500,000 lost and abandoned oil and gas wells. The American petroleum industry estimates there are over 1 million in North America. Data we do not know. We do not know how many are leaking because we don't know where they are. And if they are leaking, we don't know what they're leaking, and we don't know at what rate they're leaking what. So this is a result of research done by a student at Princeton last year, published in a peer-reviewed journal. The result of surveying a small number of wells on one piece of private property in Pennsylvania. And what she's noting here is oil and some gases escaping from this well. This well is a 1960s vintage. And I should point out that when the PADEP was notified by this student and the owner of the property of the existence of these lost and abandoned wells that had now been found, PADEP went out and plugged them. This well has been plugged. This is after plugging. So I've been saying now for 5 years, plugging does not stop a well that's leaking outside the well. So again, data we don't know. We have no idea at this point of those 1 million or so wells in North America alone that are lost and abandoned, where they are because they're lost and abandoned. We don't know what they're leaking. We don't know how much they're leaking. We don't know how long they've been leaking. And the most important thing is, how would you go about fixing that problem? Because of those 1 million, we know it's not a normal distribution. It's log normal or worse. Some of the wells are leaking like sieves. Most of the wells aren't leaking enough to care about. How do you find the big leakers? I'll leave you with that.
Matches.
Drones.
Thank you.
I'll be back.
I'm not sure I know when you're back, actually. Okay, so back to data and some numbers. I want to show you one other study. We've talked a couple of times. I just want to clarify. EPA is using this bottom-up approach again, where you need to know what the sources are, then you characterize them. The airplane flyovers, other sorts of studies are more integrated. We call them top-down. They're going to capture the totality. And they have their own sets of issues, but there are a lot of new studies of this sort. And the one that's the largest scale is this, which uses satellite data. This came out last fall. And they're looking from 2003 to 2012. This is a German satellite. It's measuring methane over the integrated troposphere air column across the Earth. So we're going here from the North Pole to the equator to the South Pole, and we're going across the Earth, integrating the entire latitude, right? So across the Earth, the methane concentration of the atmosphere grew, became more of these red colors over this time scale. The authors of that paper took a detailed look at what's going on with shale gas and shale oil here in the United States, looking specifically at those fields. They narrowed in on the Bakken field in North Dakota and the Eagle Ford field in Texas, among others, and they were able to put precise estimates on the increased methane emissions from their satellite data at this scale. Those are the numbers they gave there. That's a lot of methane emissions. This bar next to it is the one from the airplane flyover that we had published just before that. So these are comparable numbers. And I also want to point out that this is the global concentration of methane in the atmosphere. It increased a lot in the 1980s and 90s. It leveled off through here, which we don't understand why. Could be for natural causes, but it could be because the Russian gas fields were cleaned up. There's some reason to think that. Level methane for quite some time, but it's taken off again as of about 2005 or 6. And the authors of that satellite paper I just showed you say that they believe this may be due to shale gas development in the United States. And in fact, if you play out their methane emission numbers by the quantity of shale oil and shale gas that's been developed, it is the right order of magnitude to explain that increase. So this is something we can pick up at the global level. Here, I'm showing you a variety of new studies on just the upstream methane emissions. So that's our study back there, the very first published paper, the EPA estimates from 2011 and 2013, and then a whole bunch of new studies. Let me walk you through these quickly. Those are the two I just showed you, our southwestern flyover and the satellite imagery. So, we're getting up high levels of methane emissions now, 10% emissions. This one is done by David Allen and colleagues from the University of Texas. This is one of the Environmental Defense Fund sponsored studies, working closely with industry. They have a large number of measurements there They have some very talented scientists involved in it. The number is low. And when I first saw it, I've actually published somewhat of a critique on this, as have others. My initial criticism was that there's some cherry picking going on because they're only going to places and times where industry wants them to be. And it is this bottom-up approach. They're going to miss the sort of stuff that Tony's videos just showed inherently, or that our airplane flyover shows. But there might be another issue as well, and this was a paper that was published 3 weeks ago now, I guess, by this fellow Touche Howard and others. Touche Howard is an interesting fellow. He's an engineer who holds the patent on the instrument that Allen et al. Used to make those methane emission estimates. And this paper points out that unless you are very careful, his instrument is prone to measurement error. This is his wording down here. An instrument commonly used to measure leaks in natural gas infrastructure has a critical sensor transition failure that results in underestimation of leaks with implications for greenhouse gas emissions estimates as well as safety. He does not in this paper go into which previous studies might be at risk, but it alludes to the fact that this could be a problem with all of the historic EPA data and perhaps with Allen et al. So that certainly is worth looking at as well. This study down here, several different fields, one paper, this came out about 4 weeks ago now, I believe. High estimate there, these are a lot lower. Want to just point out, that's for the northeastern Marcellus. That's our study for the southwestern Marcellus, very different view. They're using essentially the same airplane flyover technology. I think they did it well, as far as I can tell. I think those are believable, solid numbers. So why is there so much variation here? Why are these so much lower? And I'm not sure I can tell you now. This is still an area of fast-moving science. But I will suggest two things. The authors themselves attribute the difference, and they explicitly talk about comparing it to our airplane flyover study. They compare and contrast emissions from wet gas and dry gas. Southwestern Pennsylvania, where we were, was wet gas. Northeastern Pennsylvania is dry gas. They say they bet the methane emissions are a lot higher in wet gas. I don't know if that's true or not. It might be. It's certainly worth looking at. The other possibility, and there might be further possibilities, is that their study, and actually our study too, all of these studies, the recent, a lot of them are short term, they're looking at non-steady state behavior perhaps, transient behavior. So let me put it in this context. These are the rigs in the United States that are being used to drill for shale gas at any time, or natural gas, but mostly unconventional gas. So we went way up there at the peak of the shale gas boom, and then we had some problems with industry. We continue to have problems with industry. When we went out in 2012 in June, there was about that amount of rig operation. A year later, which is when their study was, in July 2013, there is a huge decrease in the amount of rigs. If you think that the emissions might be associated with the rig activity, they're normalizing it to the production of gas, but the production of gas they're measuring in July 2013 is based on the previous year's rig activity. So it might simply be how you weight it, and it's a non-transient phenomenon. Good data, but we have to be more careful how we think about it. And that criticism is true of our paper as well. So I think we all need to be careful. Personally, I think this is the best estimate out there at the moment. It's the satellite data, and maybe there's something wrong with the satellite that I haven't heard yet. But the nice thing about it is that it integrates over a huge amount of time and space, and so it gets around some of these transient behaviors. All of these other studies are much short term. How am I doing for time? Doing okay, I guess, huh? I want to turn just briefly to the downstream emissions, the storage, the distribution systems, et cetera. And just to remind you that storage tanks leak. This is what the naked eye see, but an infrared camera tells us it leaks. This is the work of Nathan Phillips and others in Boston, where they drive around and measure methane concentrations, and each spike there is a elevated level of methane concentration. They put a number on what that is recently. And of course, occasionally we have spectacular gas explosions like this one in the San Francisco Bay Area back in 2010, or this one in Manhattan from a year ago. So, there is gas leaking from these places. Putting a number on it is not easy, and there's still huge uncertainty associated with it. I showed you this before, these downstream emissions. Quality of the data we use for ours is really poor. The HAHO data are really poor. The EPA data are worse yet, in my opinion, but these are all bad numbers. So there are two new studies which bear on this, and I'll talk you through them very quickly. This one's coming out of the group in Boston, Harvard, and elsewhere, taking the sort of data I just showed you and putting an emission number on it. They say 2.7% for the gas systems of the greater Boston area. And they also say that it's similar to what the industry reports to government in terms of lost and unaccounted for gas, which is what we use for our emission estimates. And we've been heavily criticized for using that because it's not an indication of leakage or emission. But in the Boston case, they've now proven actually that it is. So I think maybe our number is not bad. On the other hand, there's this study, which came out also just in the last month or two by some very talented scientists. They are going out with a bottom-up inventory approach. They're only looking at part of the distribution system, but they're looking at key parts, and they went back and resurveyed where the EPA had done their work in 1996, and they say they think things have actually gotten better and that the emissions are not as bad as EPA thinks. And I think it's an area that needs a lot more science at this point. I don't feel comfortable telling you what the downstream emissions are, as opposed to the upstream, where I think the satellite data are pretty strong. We have one other piece of information we can bring to bear, though, and that is integrating the upstream and downstream emissions, which is what we care about in the end if you care about greenhouse warming. And the best estimate for that, I think, is Miller et al., published just a couple of years ago in Proceedings of the National Academy of Sciences. I want to stress this is from data before the shale gas boom, so this is for conventional natural gas. They used observational monitoring data from a little over 12,000 stations across the United States, and they used a spatially real inverse model to apportion it to known sources so that they can try to apportion it to cattle emissions and to oil and gas emissions. They concluded that the EPA estimates are at least twofold too low, and there's quality data behind this. That means they're saying the total emissions for the United States are greater than 3.6, and they don't put an upper bound on that. I would compare it with our estimate of 3.8 that we published 4 years ago. So I think we were remarkably lucky, if you will, because the quality of the data we used were poor, and yet our numbers are holding up quite well, except for shale gas, where perhaps things are worse than we thought. So let me bring you back to a quick summary slide on that. I've learned how to make it simpler since we published our first paper. But again, we're comparing shale gas with conventional natural gas, oil, and coal. The yellow in this case is the direct and indirect CO2 emissions, and the red is the methane emissions, normalized now to CO2 equivalents using the latest protocol from the IPCC 2013 and using the 20-year time period, which I believe is appropriate given the urgency of getting methane under control. And conventional natural gas and shale gas are no bridge fuel, if you think there's any reality to what we're showing you here. Now, how the gas is used is important. We alluded to that originally in our paper. Our paper was only 4,000 words. It's actually 4,005 words, but the journal had a limit of 4,000 words, and the editor let me get those 5 words in. So when we tried to talk about the use of gas, that all got cut out. Use of gas is important because the efficiency makes a difference. So this is work, ongoing work, new work by Bongyi Hong, who's in our lab group. And he's comparing natural gas to coal for different uses as a function of the methane emission rate here. In this case, we're doing it for the 20-year comparative time frame again. So this is the ratio of the greenhouse gas footprint of natural gas to coal. 1-to-1 means coal and natural gas are equivalent. If you're above that line, it means you're better off using coal. If you're below that line, you're better off using natural gas. So this is the line for generating electricity from coal and natural gas comparison as a function of emission rates. Those are our published rates for conventional natural gas, which I think are holding up pretty well, as I say. These are from the EDF study, which could be right, they're lower. If EDF is correct, then indeed natural gas is better to generate electricity than it's coal, but not by much. If we're correct, then no coal is better than natural gas. Either way, they're pretty close. Let me finish this and come back if I could. Only about 30% of the natural gas in the United States is used to generate electricity. More gas is used for heating, commercial heating, water heating, residential space heating. So here we're looking at domestic hot water heating in a home. It would be similar for commercial or domestic space heating. Same sort of idea here, only the efficiencies are different. And what we're comparing explicitly here is a in your home, in your basement natural gas heater, which probably most of you have, right? 80% of American households that have any sort of in-home water heating used in in-home gas ones. We're comparing it with a high-efficiency electric heat pump in the basement that's driven by electricity with the electricity coming from coal. So it's a gas to coal comparison. If the emission rate is larger than 1% methane, and everything I showed you is greater than 1%, I mean everything, including the Alanol paper, then we are better off using coal to generate electricity and have heat pumps in our basement than we are to have in-house use of natural gas. And I believe that's true for space heating as well, although we're still working on the analysis. So electricity is not the whole story. The larger use of natural gas are disastrous in terms of their footprints. Oh, and now, these are not subtle differences. If we're getting up to where the shale gas numbers might be there, the greenhouse gas footprint of natural gas is 3 to 4-fold worse. Those are not subtle differences. Whereas opposed to the electricity, it is subtle difference. We don't know what the methane emissions are, so this is just a sensitivity analysis for the same analysis, generating electricity with a whole bunch of different estimates. Or generating hot water in your homes with a whole bunch of different estimates. We can see under any of these assumptions, natural gas is not desirable in its use. But it's worse for heating than for electricity. You want to take home message. What else has happened in the 4 years since our paper came out? I was really pleased when I saw this. This was published in the Washington Post in January. It's a cartoon. I think our message is getting through, and I particularly like down here, but people can't see it. So we've got the methane, only argument. I love it. It made my month. Okay, so we don't think shale gas is a bridge fuel. I feel that much more strongly now than I did 4 years ago. I think the data are much stronger. The urgency is clear. The science is progressing rapidly. And so what can you do? And I just want to mention that Tony and I have both been working hard with people to look for alternatives. We've worked particularly with Mark Jacobson and published 2 peer-reviewed studies on how to make the state of New York and the state of California free of fossil fuels within a reasonable amount of time. The New York plan calls for largely phasing out fossil fuels by 2030 using existing technologies and heat pumps of the sort I talked about and things like that. And in our personal lives, we're taking this seriously and doing things. In my household, that's our house. We now heat with a ground source heat pump, geothermal heat that's electrically driven. We use renewable electricity. This is carbon neutral. That's how I came to campus today to give my talk. It's an electric car. It's carbon neutral. So we've taken big steps. And Tony is taking a more modern approach. Ours is an 1890 farmhouse that we retrofitted. Tony's building a new house, which also will be net zero. So you can do these things today. These are cost-effective things to do. We don't need to use fossil fuels. Now let me summarize. What we wanted to do in April 2011 was to start a discussion. We've done that. There's no question about that. The new studies continue at an incredible pace. It's really difficult to track them. I'm sure I've missed some, and I'm sure there'll be new ones out next week that I'll have to read and think about. But I think there's clear evidence that we need to reduce methane emissions, particularly given potential tipping points in the climate system in the time frame of 15 to 35 years from now. We also must control carbon dioxide because it will be with us for way too far into the future with disastrous consequences. So we don't want coal, we don't want natural gas, we need to get rid of fossil fuels. But natural gas is not a preferred one. What we should do is realize we're in the 21st century and we have the technology to do something. And I'd like to explicitly thank those people. I'd also like to say that it's been one of the great moments of my life to be able to work with Tony on this. He's been a great colleague.
Time for questions, maybe answers. You pick.
I pick.
Yeah, you pick.
Sir.
I'm one of the people who lives in Ellis Hollow. You asked a short while ago, Tony. I'm wondering if you know if there are any studies or any good ways where we could get studies of emissions from the compressor station there.
I thought you were going to say, can we get data on blowdowns from compressor stations? That is a subject of embedded in one of the white papers being proposed by the EPA that could be turned into new rulemaking and possibly new regulations. Because as of now, the data is not collected. It's obviously collected by the operators because they know how much gas they're venting. They have to account for it. But that information is not reported to the EPA and is not, to my best knowledge, available to the public. You can go knock on the door out in Ellis Hollow and ask.
Well, actually, I was out there. They don't even admit to doing it that much anymore, and they've also put much better sound insulation on it, so people aren't aware of it as much.
Yeah.
Progress.
Yeah.
Yes.
Do you have any idea of the methane emissions from how much methane is being emitted from the cattle industry?
Yeah, I do. I gave a lecture on that up campus on Friday, actually, looking at the global methane budget. So these are the summary numbers that I gave for that. So it's a mixture of what's in the IPCC report from 2013 together with some constraints we can put on it. I think these are good numbers. You can push them around some. Animal agriculture is putting out about 73 units or teragrams per year, 10 to the 12th grams of methane per year planet-wide. And I compare that with about 91 for natural gas. Those are both big numbers. I think you could push that up or down by 10, 15% within the realm of the numbers. You could push that around probably 25 or 30%. It's less well known, actually. They're both big numbers. We should be tackling both of those as the big
All right.
problems.
That's what I want to know.
And there are ways to do so.
Yeah.
And these numbers, rice is a culprit. The government of China in particular has made great strides to reduce their methane emissions from rice and continue to do so. They're taking it seriously, so that's encouraging. Landfills and sewers are a big problem. We could do a hell of a lot better there too. And we should tackle all of these. I don't mean to pick on the industry there, but they are the biggest.
Luke, you just had a slide up with oil production on it, and you had an earlier slide with diesel. Most oil production has natural gas associated with it. Is that built into those numbers?
I honestly don't know. You mean this number here?
Yeah.
I don't know how good that number is, to be honest. There's very little debate about it in the literature. This is the number the IPCC used. It's the number that the EPA has been using for decades. It's the number we used in our paper 4 years ago. There's no one out there seriously questioning it. That doesn't mean it's right. So it's an excellent question. And if you believe, the satellite picture I showed you there with the attribution to the shale gas and shale oil development, the back end field is there. That's wet gas. It's liquid material. It's shale oil as much as anything else. Large methane emissions associated. It's probably not accounted for in that number.
Let me just add to that. I think that's correct, Bob, although I can't point to any government document. One of the videos I showed you was the FLIR video. That was an Eagle Ford shale oil well. That was methane emissions coming off a shale oil well. So I don't know how it's, but it's...
There are precious few studies on methane emissions from shale oil, plain and simple. And we weren't focused on it 4 years ago. The whole move to shale oil has come about since we started working on it. I think we were overwhelmed and exhausted with what we'd taken on. And I think most other scientists haven't really worked that hard on it either.
He was overwhelmed. I'm still exhausted. But I should point out that the new rule that the EPA did start to enforce on January 1st of last year, requiring green completions, reduced emission completions, applies only to new gas wells. It does not apply to oil wells.
And since they've started fracking, has there been any studies done on those wells that have been drilled conventionally as to the increase of methane coming out of those wells?
Tony?
Or the pressure in that area has increased?
I think I heard you say is...
Has fracking of unconventional wells increased emissions from conventional wells producing nearby? Is that the question?
Yes.
I'm not aware of anyone who's looked at it, but maybe Tony knows.
I'm not sure how to parse the question. Are you talking about interwell communication?
Yes.
Yeah.
Yes, there's... Yes, I can point you to documents coming out of Texas, Colorado, and British Columbia that I'm aware of right at the top of my head and I have on my laptop that document and confirm incidents, multiple incidents in each of those 3 states and provinces where there has been interwell communication. The background for that is shale gas is a spatially intensive development process. You have to drill one hell of a lot of wells. And you want to optimize the spacing of those wells, not the surface spacing, down below in the shale. So remember that shale wells, oil or gas, have laterals. Optimizing the spacing between them is an art form, and it's particular to each formation in each regime. That means that in the process of trying to get all those wells as closely spaced as possible so as to increase the rate of production, you run an increased risk of encountering a previously existing well, and you frack into that well. Okay, the most recent case I heard of was 2 days ago in Romania, or no, Albania. I don't know if you saw that. So, yeah,
Didn't see it.
70 families in one community had to be evacuated because they fracked into an existing well. I've got videos of that, by the way. If you ever want to see what happens in the surprise on the faces of the people on a well site when they're fracking this well and a couple hundred yards away there's a gusher.
Could you tell us a little bit more about the directions of your research and funding?
Well, most of what we've shown here, Tony's a professor emeritus who had an endowed professorship. I'm an endowed professor. So we had funds from Cornell University, which we get as part of our positions, and that's the majority of the funding. The David R. Atkinson Center for Sustainable Future at Cornell gave a grant to Jed Sparks to work with us on it. They actually paid for that airplane flyover stuff from Purdue, which I'm very proud of the university for having done. In addition, I have received funding from the Park Foundation and continue to do so, and I had a small grant from the Wallace Global Fund to do the heat pump comparison work that I just showed you with Bongui Hongs. Our work, we'll continue to do some analysis of the use of the gas. My take is that there are an incredible number of talented people out there making these measurements now, and my ability to add materially to that is relatively small. So I think we've gotten something started, and I'm happy to watch other people do it and try to sort of observe and interpret now and then.
I do the same thing as Bob. I'll start with the funding. I personally have never taken anything other than my Cornell salary up until the point that my Cornell salary stopped, which was July 1st of last year. I'm now broke. But since then, I have taken no money from anybody else either for the work I do. It was all, as Bob said, as a result of my being paid by Cornell to do it. Renee Santoro is on the staff of PSE Inc., Physicians, Scientists, and Engineers. Bob and I were founding board members of that. At one point I was president. I'm no longer president. Renee, for all the work she's done with me since on the papers we published, is being paid out of money that is being gotten from philanthropic organizations. I'll name them: Park Foundation, 11th Hour Foundation, Civil Society Institute, Heinz Foundation, Clenio Foundation, Colcom Foundation, maybe one or two others I missed, and donations from people going to our website and hitting the button donate. So everybody on the staff, we now have 5 full-time staff members in PSE, are paid salaries that are derived by donations either from private individuals or from philanthropic organizations. What I'm doing right now, first, is following up with the second paper on wellbore integrity issues in Pennsylvania. That paper will be reviewed by the Pennsylvania Department of Environmental Protection before we submit it to a journal, which I see as a good sign. They reached out to us and said, we got a new governor. We got rid of all the porno freaks that used to run PADEP. Their words, not mine. And so a new era of transparency, openness, and collaboration. We'd like to sit down with you and see the paper and give you ideas on how it can be improved. So we're looking forward to meeting with them sometime in the next couple weeks. I'm also continuing to work on downstream emission measurements, including those local to where we're standing.
I will add one other thing I'm engaged in as a research topic is how to better incorporate methane and carbon dioxide comparisons into life cycle assessments. The policies out there for doing it are a little ad hoc, and we all do it a little differently. And to the extent that anyone follows a written protocol, it comes from the Kyoto Treaty, which is hugely outdated in terms of its science. So I'm the task leader of a group for the International Standards Organization to try and put more rigor into how that could be done in a modern way, following the new IPCC data.
Can either of you comment on the greenhouse gas impact of the NYSEG-Iberdrola proposed West Dryden pipeline?
Did we anticipate getting that question?
You go first, and I'll chime
Okay.
in. Or
Actually, Bob and I anticipated that question, given, and we agreed to agree on perhaps disagreeing on our agreement. Let me explain what I mean. So Renee Santoro, I asked her to do some calculations, and they've been since confirmed by a few others. If the proposed gas flow rate in the pipeline that's being proposed to pass through Dryden, if the proposed gas flow rate is all burned, it's an easy calculation to do, how much carbon dioxide is emitted. And that turns out to be somewhere around 28% of the total carbon dioxide emissions in Tompkins County. So it's not an insignificant addition to CO2 emissions in the county. But of course it ignores what we just talked about. How about methane emissions? So there's no doubt that the methane flowing through that pipe had to have come from some upstream sources, all of which we just talked about. And there is no doubt that the methane flowing through that pipe that goes into the distribution system in Ithaca, some of it will leak. So that 28% is a lower bound. And we don't want to focus so much on CO2 as we want people to understand that it's just a darn stupid thing to be doing at this point, to be increasing fossil fuel deliveries to Tompkins County, when Tompkins County, various agencies, politicians have all claimed that Tompkins County is going to reduce its CO2 equivalent emissions by 80% by 2030. I mean, you can't do the pipeline and meet that objective. You just can't. And we're doing such a good job in Tompkins County as being an outstanding county in increasing the rate of renewable deployment and decreasing our demand for fossil fuels. So the pipeline is exactly the wrong thing at the wrong time for the wrong people.
I think that's a great answer. I agree completely with that. But the carbon dioxide view is a lower bound. And you put in any reasonable estimate for the methane emissions, which is astronomically difficult to do as you scale it down, which is why we are futzing around with numbers. It makes it astronomically worse. But we don't want to put a number on it. I mean,
can you go back to your slide about electricity that's generated by coal versus gas?
that one, or yeah, this one?
Yeah, so that top graph, and I wanted to get some clarification there. As probably some people here know, I've been fighting about the conversion of the Cayuga power plant from coal to gas, and a lot of that argument has been based on the environmental impacts of doing that. What I wanted to find out in this, where you say it's kind of generating electricity, it's kind of 6 of one, half dozen of the other. I wanted to find out, does it depend upon the type of efficiency of the furnace? In other words,
Yes,
is that looking at combined cycle as compared to, so is that, yes, it does depend upon the efficiency?
It very definitely does.
Okay.
And to be honest, I don't remember the exact details behind that calculation. I'm not sure Bungie is here either. He could answer it. We have a manuscript that's out for review on it, so we have the detail. I can share that with you.
Okay.
And I will also tell you that we have the ability to make these calculations and change your assumptions as to efficiency. So we have a web-based calculator that lets anyone do that, which we're beta testing with about 200 Cornell students at the moment, and we're prepared to go live to the public within a week or two.
Right.
So you can look at it yourself and decide and apply your own based on the efficiencies you want to put in there.
Yeah, and does this take into account the upstream effects? Or
Yes,
not?
yes, it does.
It does.
Yes, so well, as a function of methane emissions. So those are our total life cycle methane emissions from upstream to downstream for conventional natural gas. I think shale gas is going to be pushing it way out there. And of course now,
Oh, that's for conventional.
that's for conventional natural gas, yeah. So this is a pretty conservative view. This is making natural gas look about as good as you want, I think. And I do believe also that this is for combined cycle natural gas, but don't
Okay.
hold me
And-
to it,
and
I'm
so
not
not
sure.
for the kind
It's
of
also for a
inefficient-
reasonably efficient coal plant.
Okay.
So, but again, we have the calculator. You can play with it and see for this plant, do this versus that. put a methane emission in, play with the life cycle time you want to use. You can do all of it yourself if you don't like our assumptions. We want to make it as transparent as possible so people can see what's really driving these conclusions.
Okay, great. I'm also going to just take advantage of this audience to distribute some postcards that we're sending to the Public Service Commission opposing the power plant. I would be happy to collect these from you at the end.
Okay.
Next question.
I have a question or possible challenge on measuring the distribution. You talk about upstream and downstream. I guess they're stripping ethane in the middle. I don't know. But in terms of the downstream stuff, it seems like your numbers are pretty low. And so are the. I worked my way through college doing methane surveys, natural gas leak out all over the West. There were towns where they were blowing more methane up through the soil than they were delivering to the houses. They were delivering natural gas through holes in the ground where the pipes formerly were before they corroded. So that's why this number seemed kind of tiny. Now maybe infrastructure, gas infrastructure now is 100 times better than it was back then.
Yeah.
I doubt it. I'm just wondering, there seems to be a lot missing here. I mean, there are master
information. So in our derivation here, we were trying to be conservative. And what this number is based on, two things. There's a European study, which is lower than this, and then there's what I consider to be pretty good data on lost and unaccounted for gas, what goes into the pipeline versus what comes out of the state of Texas. We use Texas because their accounting system seems more reliable than the U.S. average as a whole. And that gives you a number like 3.6 or something.
In Southern California, where they share pipelines, they should have figures by calorie.
But in terms of new data, if I'd given this talk 2 months ago, I would have told you there are no new data, but there are since then. The two studies, the Boston one, which gives us a number of 2.7, which is similar to their lost and unaccounted for stuff. And Boston's a pretty leaky city, so I think that's a good number. And then there's this other sort of bottom-up stuff by people who I really do trust. They're good scientists who tell me it's going to be down in this sort of number. So I don't know. My gut tells me, yeah, it should be higher. I agree with you, but I'm trying to be driven by the data.
Well, there's private companies that have been doing this since the 30s, and every place where there's a every place where there's a system, they must have massive amounts of data and experience as to what the distribution losses are. And I mean, Boston, whether it's leaky or not, that's where these companies originated. They're likely to have been plugged more vociferously than the rest of the country, because that's where Heath Consultants in these other countries
it could well be. And
are. So
if I had to point to a research priority, it would be to nail down that number better.
Yeah. I mean, once it gets to the houses,
and it's possible to do it.
We used to do meter tests all the time and watch. Look for leaks by watching the dial spin when we turn everything off in the house. So there's a lot missing. There's a lot missing from that.
Yeah. No, I think it's the biggest unknown. And when we did this 4 years ago, we were full of unknowns. I think the upstream stuff is more certain, still uncertain, for the reasons I gave you, but we're getting more information, more certainty. This we're just beginning to learn about with better data.
Thank you. So it seems to me there's a real lack of critical analysis of the EPA Clean Power Plan. And the way it looks like to me is just converting a bunch of coal-fired power plants, as connected to his question, to natural gas. The way they're framing it is all of the Republicans hate it and all of the Democrats and good environmentalists love it. Can you talk about that?
Well, it's an effort to close down coal plants. There's no doubt about that, and to move and let states have some leeway in how they do that. And certainly, moving to renewable and increasing efficiencies are highlighted, but so is the use of natural gas. I think that's inappropriate, and I think the Obama administration has gotten stuck in a difficult point in time, because I think they got on this trajectory of thinking this was a bridge fuel early in the president's time. There were other big greens who were pushing that at that point in time. It wasn't just EDF, NRDC, Sierra Club, and others were as well. I think a lot of those groups have backed off, not only because of our argument and research, but in part because of that. I know the Obama administration has had internal arguments as to how far they want to pull back. they clearly decided to keep that on the agenda as part of the bridge fuel argument, but I don't think they're unanimous about that. Secretary Chu 2 years ago was saying that, they looked at it and our data didn't seem credible. It's a reasonable thing to say, because the quality of the data we had were poor, as I said, and there are a whole bunch of papers saying we were wrong, and most of the new information I've shown you wasn't available. As it becomes available, as a scientist, I hope it will influence the broader community of scientists and the policymakers who are driven by that, and we'll see a progressive change there. But it may take a few more years. Is that fair?
Thank you all for coming.
Nothing worse than a crap out of